Anis, thank you for thank you for your short introduction of myself. Okay, so I would like to share my screen. Okay, can you see my screen?
Yeah, we can see your screen.
Okay, that's good. Okay, okay, first of all, I want to know if there any foreigner or overseas student participate this webinar, or all is a Malaysian? I think
I
all is
believe
a
almost all Malaysian.
almost all Malaysian. Okay, so my medium today will mix lah. I will use English and maybe some part I will use Malay lah. Okay, as mentioned by Miss Anis, I will do my presentation first, and then if you guys have any question or you want to ask me, you can send your question to Anis by chat box, and at the end of the this webinar, maybe I will stop. We are scheduled 9 to 11, so maybe 10:50. I will 10 minutes earlier. I will stop lah for the Q&A question. I think it's enough. 10 minutes,
Okay.
or you want more? Okay. Actually, I have 70 slides to present today. Okay, this is my topic today. So as you can see, I have 10 topics here. I will start from introducing my background again. And then since today we are talking about the vacuum, so maybe you guys also wondering what's the vacuum eventually. So I will introduce on the vacuum introduction by the characteristic and then the technology, vacuum technology using surrounding in our life. And then next, I believe all of you are now further study in related vacuum technology. So you wondering what type of career, where is the segment of field you can go after your completed your study. Then number 6 is on the job qualification and role, your function when you are working at the industry in Malaysia. And then to fulfill your role, what is the skill required and what is the useful tool you can be used. And lastly, number 8 is a vacuum technology player in Malaysia. You can start to plan for your next career. And as per our topic, I'm working in the Japanese company. So I would like to touch a bit on our Japanese working environment and also the challenges and the solution working in a Japanese company lah. Okay, first we go to the my background lah. So my name is Shariza bin Sabri. This year I'm 43 years old, and as explained earlier, I graduated from Japan, Kitami Institute of Technology in Electrical and Electronic degree, and then I further study on MBA, specialized on engineering management at UNIMAP University in 2017. Okay, this is my working experience. Just want to emphasize that on the Sony is more my experience more on the manufacturing electronic as a production engineer. And then at the college community or KKBDA, I involved in the education, teaching on the engineering subject. And then after that, I joined ASBIL as a service support instrumentation engineer. And then that one is a instrumentation field. And then I jumped into the semicon. So Tanaka Electronic is manufacturing for bonding wire. We have a gold bonding wire and also aluminum bonding wire. This is more on the back end semiconductor for the packaging processes. And then here I'm working at Alvec. Valvec is we are supporting various field, various industry, and we are supply vacuum technology on component and also equipment lah. And I have a 2 years experience working in Japan at Alvec HQ. Okay, I would like to briefly introduce where is Alvec Malaysia lah. Basically, we have 3 location. Our HQ located in Bukit Kemuning, Shah Alam. We are doing on the sales, overhaul, and also shield surface cleaning division. And then we have nearby, also at the Jalan Bukit Kemuning, we have a bonding factory. And then lastly in Kulim. I'm from Kulim. So we have a workshop for the maintenance and also supporting on site for the customer. Mostly is in the semiconductor wafer fab technology customer. Okay, this is about Alvec. I'm not going to talk it deeply, just to mention that our product is including vacuum pump, oil and dry type pumps, system, services, surface heat treatment, target bonding, and also after sales service. Our main industry, we are supporting semiconductor, flat panel display, PV or solar, automotive, electrical, pharmaceutical, packaging, and also others general industry. This is the Alvec global network. Is founded in 1952 in Malaysia. Now we are nearly 60 years old, and we have more than 50 group company worldwide. We have in Japan, China, Korea, Taiwan, US, and also Southeast Asia. Okay, for Southeast Asia, I can say each country, we have a sister company in Alvec Malaysia, Singapore, Indonesia, Vietnam, Philippines, and also we have India under our SEA area. Okay, first, what is the vacuum? I think maybe you already know the vacuum since you are student in micro E, and I believe you study a vacuum also. Just like to briefly speaking lah on the explain on the vacuum introduction. Okay, vacuum derived from word Latin of vacuus. The vacuus is meaning of empty or void. That means is like as the picture, a black hole. Inside the black hole is nothing there. We don't know what's inside. Is a void, is empty. Okay, then to be more accurate, in a sign, the vacuum defined as a region with gases, the pressure less than atmospheric pressure, ATM. Currently, we are living in a normal ATM pressure. So when you have a condition that the gas pressure is less than our ATM, that we call vacuum. Okay, for example, okay, this is one of our factory in Japan, Alvec in Susuno. Behind there is Fuji mountain. So I believe you all know about the Fuji. So Fuji is about more than 3,000 meters above sea level. So when you go up to the mountain, the air gets thinner and decrease. The pressure will be decreased. Or it's a low pressure, where you can feel like difficulty in breathing because breathing because of the low oxygen level. This is due to the low pressure. But we don't say that a vacuum in our normal daily conversation. But that in the sign, that condition is already start vacuum condition. So vacuum is not completely an empty condition. It is very difficult or very challenging. We want to get a really empty or 0 Pascal condition. So the vacuum actually is also filled with pressure, but the pressure is lower than what we feel currently in ATM. So in ATM currently, our body, we are experiencing the pressure 1,500 Pascal, or we call 10 power of +5 pressure Pascal. So this is the condition what we are experiencing currently. If you can see on the right chart here, we are at the ground here is 10 of 5 Pascal. And when we go up higher to the sky, the pressure will start to drop. So the rocket actually is about 10 of -1 Pascal. And the satellite orbiting at 10 of -5 to 6 Pascal. That is the vacuum pressure. So in our industry, of course, when you are handling with the vacuum machine, vacuum equipment, you will deal with the sort of this pressure. So we categorize the pressure by extreme high or high vacuum, low vacuum by this pressure scale. This is a region of vacuum that you can see. Currently, we are ATM pressure is 10 of 5 Pascal. And when it's dropped a bit, 10 of 4 to 10 of -2, we call it low vacuum. Then it's starting to reduce, the pressure start to reduce to medium, high, ultra, and lastly is extremely high vacuum. So extremely high vacuum is about -15 Pascal. This is what human can create existing. But in outer space is much lower pressure, and perfect vacuum or ideal vacuum will be 0 Pascal, and we are unable to create to the 0 Pascal. Okay, vacuum in our industry, the vacuum or the low pressure is created by using a tool or equipment. Majorly, we use a vacuum pump. Specified vacuum pump, we have a vacuum pump that can generate vacuum from the low until to the extreme high vacuum pressure. Okay, now you already know the vacuum term or vacuum definition. Then next, we want to know detail what is the characteristic of a vacuum. Okay, firstly, the vacuum, it reduces oxygen. That is why when you hiking to the high altitude mountain, you can start feeling less oxygen level and difficulty to breathe as normal. This is because when the lower pressure, the vacuum is higher, and lower, it will create lower air or oxygen. And anything that oxide in the air react with oxygen can deteriorate, can be keep in vacuum to maintain its condition. And then in the vacuum, you won't able to hear any sound, because sound to transfer in the air is required vibration. It's the vibration transmit the sound in the air. So once it's vacuum, there's less gas, less molecule that can carry this vibration. So there is no sound can be travel in the vacuum. And then third one, in the vacuum also, vacuum does not conduct electrical. So as you know, electrical actually is the transfer of movement of the molecule from A to B, B to C, and it will start to exchange. As you study in the chemical, the outer layer molecule will fulfill the another void, and it start to transfer the electrical. In the vacuum, because of this less molecules, then electricity also difficult to conduct. Vacuum also can be used as an insulator. That's why one of the challenges in the vacuum, when we want to make a product in the vacuum condition, we need to consider how does the electricity can be conducted. Okay, the fourth one, vacuum does not cool down or cool up because of the, as mentioned earlier, when we, for example, we have a cup of coffee, the coffee from the hot is become cool because of the phenomenon when the gas molecule inside the air, molecule in the air collide and it lose the heat. However, when the condition of vacuum, the molecule are blocked, so the molecule cannot be transferred, and the heat will maintain as there as long there is no leak. Later I will explain on the product that using this concept. Okay, and lastly, in the vacuum, the boiling point will falls. When in our normal atmosphere, when we boiling a water, we require nearly 100 to boil 100 degrees Celsius to start boiling the water. But in vacuum, because of vacuum characteristic, we can boil the water at the low temperature. Okay, next application using by vacuum technology. Maybe you won't imagine the vacuum technology in our daily life. Actually, everywhere we can see. Vacuum technology can be used from automobile, semiconductor, on the TV flat panel industry, for the solar panel, food processing, on the aircraft, biotechnology, phone, magnetic, and so on, as you can see on here. A lot of daily product we use, it involves a vacuum in the manufacturing process. For the example, the product surround us is TV. The panel is using a vacuum machine, and mobile phone from the chip into the screen panel into the layer of coating. And then on the automobile, when we there's a product, electronic product, and also a product that required for the leak check, like fuel tank, rim, tires, and we have a coating for headlamp. Also, we'll use vacuum technology. And for the general industry, like the shaver, for the blades, and then for the optical, the coating of lenses, and then home appliance, those products are using compressor. It's required for the leak check. We'll use a vacuum. And then for the food and medical industry good also, dry process. This one of example, chocolate. When they vacuum it, it become expand. You can see the void inside, so the chocolate will be more crunchy. And on the preparing of the medicine, from the solution to the powder and packaging, also required vacuum technology. Okay, this is okay. This is the pressure in the vacuum. Later I will show the vacuum used in industry. We have like rough, high vacuum, ultra high vacuum. So by categorize of this type of vacuum, what industry can be used and what the application and end product are used by them. First, rough vacuum. Rough vacuum inside, you can imagine like this 3 chamber. Inside the chamber, we still have a molecule that freely can travel inside. That is a rough vacuum. And then we have a lesser molecule inside travel. We have a more free pathway, is a high vacuum. And then lastly is a ultra high vacuum where the molecule are free, like the highway. The free path is very high. They can move without lesser collision. So the industry, as mentioned here, we can use for rough vacuum, food processing, evaporation, freeze drying, sputtering, electrical conducting, and so on. And the high vacuum is for like this: heat treatment, IC manufacturing, decorative or ornament coating, particle acceleration like SEM machine, and then E-beam welding, vapor deposition, and ion implanter for the semiconductor. And the higher ultra high vacuum, in this condition, it can be used for the space research, material, metallurgy, physics, molecular beam, and epitaxy. Recently, epitaxy are widely been used for the LED manufacturing maker. And ultra high vacuum majorly is for the R&D purpose. Okay, this is the application that can be used. As I mentioned just now, in the ultra high vacuum, we have a large mean free path. So the objective here to avoid collision, we can use like for the electron tube, X-ray machine, mass spectrometer, and molecular distillation equipment. Okay, next, for example here in our smartphone, if you can see on the smartphone, vacuum are used to make a lens, CPU for the memory, microphone, sensor, and also the tantalum capacitor here. Flat panel, we have a special silicon oxide coating and organic ELD and so on. So this one is using we have in semiconductor, we do have a evaporator and sputtering. Okay, this is a principle of evaporation. I think you all know about this one, so I won't describe more. Just for the major deposition in the evaporator is for the low melting point material like AG, aluminum, and so on. It's less than 1,600 K and used for the organic material. And then we have electron beam. Electron beam is suitable for the high melting point, majorly aluminum, chromium, molybdenum, platinum, nickel, titanium, and so on. And by using the electron beam, we can get a high speed deposition. Mostly is for thick film formation. You can get a very thick film at the Armstrong level. And then sputtering. I think UTSM also that you are using a sputtering machine. So the sputtering is using gas, normally under argon gas atmosphere. It will discharge and make a thin film coating here. So the material is suitable for metal insulating material, and the advantage is a high quality coating compared to the e-beam and evaporator. That's just now is more on the semiconductor industry. And next, in automobile. In automobile, where does the vacuum use? As you can see here, all of these products are using vacuum processes as well. Headlamp. Headlamp, we can see it's like reflection. The reflection is last time I was taught is from sort of glass. Eventually, is from plastic coated with the some material like aluminium, aluminium oxide. So it make a reflect characteristic. And then in the process of rare earth material for the battery, it use vacuum furnaces, and to make a capacitor also use a vacuum, and then electrical parts, microcontroller are using of the thin film coating machine. And then for the engine, heat exchanger will use a vacuum leak check, and we do have more others also. Okay, next on okay, this is the automotive lah. Automotive, you see here is coated by aluminium for the reflection. The mirror also is a coated process using an evaporator. And for the tire rim, we have to ensure there's no leak. So it's using a vacuum automated leak tester equipment. And fuel tank also, to ensure there's no leak, because the leak in the fuel tank will lead to the fire explosion. And then for the engine part, the engine part are using it require a strengthened metal, and this metal like the crankshaft using of a heat treatment process. Another vacuum application for the low pressure. So low pressure vacuum about 10 of 1 Pascal. It can be used for the transferring, pick and place process like vacuum tweezer, vacuum filter, and also some forming product also. It will be heat up, and under the vacuum condition, it will shape by the mold use. And also, as you all know, vacuum cleaner also is one of the application using vacuum. This is a low pressure vacuum. Okay, next on the vacuum application for the low molecular density. Vacuum flush. Okay, vacuum, why does the liquid when we fill here, if cold is remain cold and if hot is remain hot? Because the vacuum flush here inside the body is vacuum conditioned. So in the manufacturing process, they will make this bottle, and there's one hole, and vacuum pump will vacuum out, pumping out all the air inside here. After it's been vacuumed, then it will welded. If you notice on the bottom of the vacuum flush, there will be a one hole used for vacuum out, and they will seal it to ensure there's no leak. So the air inside the inside here, there is no molecular, so the heat cannot be transferred out. And then for the freeze dryer, this for the food industry, we can have a lot of dry fruit, and normal dry fruit and freeze dry fruit, actually there's a difference in terms of the shelf life, in terms of the preservation of the moisture, and it tastes also. And then vacuum glass, like for example of the building, is directly under sunlight, you will feel hot inside. But by using a vacuum glass, where there's a 2-layer glasses and inside a vacuum, so the light cannot transfer its heat. Just we have the light only. And then for the large mean free part or the ultra high vacuum, we use for the, like this one, the pecutan zarah, or the to speed the molecule is cathode ray tube, and then mass spectrometer, which we use to detect on the gas type used in the chamber, for example, or the X-ray machine. And then on the deposition system also, it will use last mean free parts application technology. Okay. Next example of the product and how does the vacuum use into its process. First is dry food. Dry food, medical, and instant coffee. Vacuum dry using to remove the moisture. So when moisture has been removed out, the product will be dry, but it's preserve the condition. When we put the water back, it will resume or become to the original back. And then antioxidant for the food, for the fruit preservation. When we remove our oxygen and we do the packaging, actually we are removing the oxygen. So as you know, oxygen making the making the fruit oxygen can preserve the food. Okay, this the heat.
If I may ask, how do you vacuum oxygen only, or you just vacuum it out everything and then you just put nitrogen inside there?
This one actually is depend on the condition, but for the food industry, normally what they do is they remove all the air inside, not the oxygen only.
Okay.
Actually, the food they throw it mainly because of the oxygen, but to remove out the oxygen only is quite difficult. So they remove all out. So basically, there's no gas inside lah.
Okay. So it's like if we have the chip, a potato chip. Sometimes they put into a nitrogen pack potato chip to make sure
yes.
to preserve the quality of that, right? So they remove everything else and then they put nitrogen only. So nitrogen is the inert gas, right? Not inert, but not no oxidation lah. Okay, thank you.
Yes, for no oxidation. Yes, as you mentioned, there's a lot of product also. After completely vacuum, they will put they will push the nitrogen back. This one I'm not sure what is the purpose, but one of them is to make the preservation become longer lah. Maybe as to keep the taste also lah. I'm not sure, but need to confirm lah.
Okay, thank you.
Okay. Okay, then next on the heat vacuum pot. Okay, vacuum pot already mentioned earlier. And then on the degassing process. Degassing process is from, as its name, to outgas. So it's removing all the gas, all the air from the material to keep the material quality. For example, in the industry, the lipstick or the sealing material, O-ring material, they have to remove the air inside. So it's using a vacuum process as well. And then in the major application, this in for the aircon manufacturer, they are using very lot vacuum application. All the process. This is the example of the aircon or compressor lah. The compressor that used in fridge also is similar process. They will have a recovery system. They will have the system to from the pre-evacuation, and then the charging with the gas, helium, and then they do the leak test, and then they fill in with the refrigerant gas bag. So this cycle involves a lot of vacuum process, and if you can visit aircon manufacturer, you can see there's a lot of vacuum pump using in their processes. Okay, next on the semiconductor. On the process of semiconductor, for example, here in deposition. So deposition, they want to deposit another material inside. So we use sort of equipment like CVD, a chemical vapor deposition, or another type lah. They will put the gas, vacuum, and it will deposit the material. So this is what we call bonding material. So let's say you want to deposit on some metal. So the metal are put here by the bonding process, and then at a high vacuum, at a high vacuum, you will discharge the current. You bombard here, and the gas will bombard the material here, and it will start to make a thin film coating here. So it's used for like here, we in the IC diode, on the logics IC, and the memory, and also many mostly the IC product lah will use front end semiconductor lah will use of this process. Okay, another this is the another application can be used with a vacuum lah. Before we go to the next topic, number 5, career in vacuum technology. This is the process also can use of vacuum. In pharmaceutical or medical, they use sterilization. So for example, the operation theater tool, scissors, knife, everything. After they fabricate, they will do the surface treatment. Surface treatment by the vacuum furnaces. So it will change on the like hardening of the parts surface, and then to make sure, because the operation theater in the medical, the thing need to be sterilized, and they will put under sterilized vacuum sterilization equipment. And for the space chamber, also can using for R&D lah. They will use very huge vacuum pump. For example, Alvec also have pump used in Japan, JAXA lah, for the JAXA, like the NASA, they have using Alvec, the biggest cryo chamber in the world. And for oil purification, this one like our voltage distributor, when the process here need use the inside this one is a oil. So the oil cannot be mixed with gas, the ATM, because it will make a short circuit. So this process also using a vacuum pump. Vacuum will vacuum out all the gas inside and will pumping in the oil inside this tank. And then freeze drying and also vacuum packaging and others lah. Actually, there's many others industry involved with vacuum, but I just focus on what we have experience in Albec only. Okay, next topic. The next is carrier in vacuum technology. From the previous slide, you can imagine actually there's many industry involved with a vacuum. So if you are looking for carrier in a vacuum technology related, there are many in Malaysia. Firstly, in the general industry, and then automotive, heat treatment, food industry, medical, pharmaceutical, and aviation also we have. I will explain later. And then on the semiconductor, wafer fab front end, or we have a semiconductor back end also, which we have many players in Malaysia, especially in Penang, Kulim itself. And then for those for the LED manufacturer also, and solar panel, PV of flat panel or display for the TV, and energy battery for the car, automotive, or also for the smartphone related. And lastly, in education also is using a lot of vacuum technology. Okay, for when you want to work in this vacuum technology field, so maybe you will what position, what rank, or what type of job you will involve. Here I just rough. Okay, this one is what to call most of the industry, they will have sort of these processes. So when they want to sell or develop a new product, they have a R&D team. R&D will do the testing, and will do the initial testing evaluation, and then once product is confirmed, they will pass to the procurement or sourcing division. So sourcing division will looking source out what is the material, what is the technology, what required for the production process, and then the production will make a planning accordingly, what of the equipment they are going to use, and then how many members, how many engineers are required, and then next process will go to the production. So production, they will start from the production process, trial, manufacture, trial, mass production, and when the product confirmed, secure, they will start on the mass production MP. And of course, when the production is running, they will need a team for the maintenance. So the maintenance guy will ensure the machine will have a low downtime, and then lastly, it will when the product is ready, they will hand over to the next process for the testing and quality. So the testing QA, quality assurance division, will do the required testing, and once the parts confirm, it will ship out to the market. So every block here, process here, it will involve a person with knowledge in a vacuum technology. Even though like sourcing also, to source a product, to source the equipment, they need a guy that can understand on the process also and the material as well. So you would be in most of the students, they will imagine that after graduated, they may be working in R&D or production in production only, because it involved on the engineering knowledge or technical know-how. But eventually in the industry, all of this required a guy with knowledge for the vacuum, because it's a chain process. So maybe you will start working with production. When you know the production, will involve in maintenance. Then when you know maintenance, maybe you can be the sourcing also. Because when you sourcing, you know what is the part, where is the machine required. So I can say you can be in any division with your knowledge. So this is a required multi-level of position and also multi-skill as well. Okay, next on the general. Okay, so just now you will be involved in a lot of division or lot department support. So which industry? So next on the industry that you will you can work, you can use or you can implement on what have you study in university. So you have a in general industry. For example, here actually there's general industry, there's many. I just highlight on a few. For example, on the here on the agriculture, on the what to call agriculture, you can use vacuum to remove unwanted portion of poultry processing plant to because when you do in a huge scale, you need to optimize the production and energy efficient, and they will use a vacuum. For example, here vacuum solutions to use here to separate product that they are not required employee to handle manually. Like when you after you slaughtered the chicken, last time to remove of unwanted part, to remove the fur, you need a manual process and it's consume a lot of time. So by using a vacuum also, by using a vacuum, it can enhance and can make the products can increase the productivity. And then for the process here, like shaping of the here molded fiber, this one also using of vacuum. And then in general industry, wood preservation. For the wood preservation, after the wood had been cutted, then to preserve it, they will use some chemical, and the chemical used with in a vacuum machine with pressure. But this one might be less the industry in Malaysia, I'm not sure, but since we have a lot of of the balak industry, maybe it can be implemented as well. Okay, next, automotive. You can work in automotive industry because we have quite numbers of automotive player in Malaysia. We have Proton, we have a Prodor, and then there's a supply chain to make a product. And we have a car assembler like Nissan, Toyota, truck, Hino, and also the luxurious car in Kulim under Inocom, Mazda as well. So there's many job opportunity in this automotive industry. For example, here this is lighting reflector. Lighting reflector. This example of the equipment. This equipment is made by Alvec. So they put the product, they hang product inside here, and it use this one using of evaporation process. So to make this reflective, it will coat with protective glass like silicon oxide on the top coat. That's why it's shining. So also for the decorative part, sometimes we can see that the part look like a metal, and the color have a like multicolor, which can change of by the degree we're looking on it. So this also are using same equipment like this. And in automotive itself, to ensure this all product working well, they're required for the leak test. So the equipment will be used here is auto leak tester, ALT. For example, aircon process, airbag, component, radiator, air cooler, plastic tank, wheel, and the fuel tank. In Alvec itself, like for component of airbag, we do support one customer in Negeri Sembilan, which are using our equipment. So inside the airbag, when the car had collide accident, the gas inside will burst. So when the gas burst, the airbag will come out. So they put the gas inside that unit. So that gas need to confirm there is no leak. So it's using a ALT process. And for the rest, also actually there's a many supplier in Southeast Asia. We do have a sort of similar player in Malaysia, Indonesia, and also Thailand, because these three countries actually they are support of automotive chains in automotive chain supply widely in Southeast Asia. Okay, next on the third one is heat treatment. Okay, heat treatment. There's a lot of processes in the heat treatment. Based on the application, it will use a different application. So I list up a few applications here. First is a vacuum brazing. So vacuum brazing, you can see here used to various heat exchanger and thermostat between metal and non-metal part. So you need to brace of this part, and it use heat treatment. For example, this is the heat furnace equipment. This is about 1 to 2 meter high. It's very big, and the parts will put inside and will be treated under high temperature in the vacuum condition. So as I mentioned earlier, in the vacuum condition, the melting point is lower. So that is why we can use that's why they prefer to use vacuum, because they can save on the energy. No need to use a high temperature for the processes. And then vacuum sintering. Vacuum sintering is used for various metal and ceramic powder, like in a petroleum exploration. The resistant nozzle here is treated by vacuum sintering process. And then on the latest industry, automotive or high-speed train, they will use a magnet inside. For the magnet, neodymium iron magnet treated by this vacuum sintering equipment also. Okay, then we still same topic in heat treatment. For heat treat, in the heat treatment also you can have a chance in opportunity for the quenching furnaces. So these quenching furnaces is used for the quench and tempering of the various metal steel. For example, here in general product where we use shaver for each blade, it will treat by this vacuum quenching furnace. And then you have for tool industry, and then for the stainless steel, and also for the engine part. That's the engine can be used for the automotive and also for the aviation. We do have a aviation customer also in Subang, which they are using. They are doing the treatment on the Fokker blade. So as you know, Fokker, the engine it come with propeller outside. So this propeller, after a few thousand hours, they need to be treated back. So they are using of this quenching furnaces. Okay, then next industry that are possible to use vacuum technology is bottle filling. Okay, to fill in the bottle, actually the normal process and atmosphere also it can be done. Just fill in the liquid inside. But for some industry, like pharmaceutical, medical industry, they have to ensure the product that to be filled in safe. So they have to clean inside, sterilize, vacuum by using the vacuum. They will vacuum out the air, and then they will push in with the liquid which they want to fill in. So this also will use vacuum. And for the normal beverage industry, the reason they use this method is to remove oxygen from the bottle. As you can know, the oxygen will react with the beverage. It will mix the. It will mix. It will make the flavor or the aroma change. That's why oxygen had to be removed first, and it can compromise the taste and aroma of the drink. Next, on the agriculture, we have a vacuum cooling. This vacuum cooling for like Cameron Highland, there's a few players already started to using vacuum cooling method. The difference of vacuum cooling method with the normal freezer is when you use a normal freezer, for example, after harvested of the leafy vegetable, they will put inside the refrigerator. Refrigerator first, it will take a long time to cool it down. And then once it's cool, it will make water inside. So this water will harden as an ice, and it will change the vegetable texture also. But by using the vacuum cooling, after harvested, they will put inside the box, put into this like container, and close down, and they will vacuum it. So in the vacuum, to reach a low temperature is take a short time only. We did for the by using a bigger pump for this size container, they can they're able to lower down the temperature within 30 minutes. Then once it been vacuum, that means all the water rich inside also had been taken out. So they will then they will ship it there to the user lah. And benefit of using this vacuum cooling is not only the lower down temperature is higher, but actually it can prolong the shelf life. For example, cabbage, the normal cabbage using a conventional method, it shelf life about 15 to 18 days only. By using a vacuum cooling, it can prolong up to 28 days. So our product can be shipped out overseas. For example, I have a customer in Cameron Highland. They ship out for the Middle East. They send the vegetable for the Middle East market by using this vacuum cooling method. And not to the vegetable only. Some of the packaging customer, some of packaging player industry for the flowers, for the fruit also starting to use the same method because they want to extend more to the other side lah. And as I know, like Singapore also, they required some of the product required to be used vacuum cooling technology. It's become a requirement nowadays. Okay. Next, for the medical and pharmaceutical. Okay, medical and food actually is same industry. So they are using same method, same requirement. We in this both industry, vacuum freeze drying, vacuum cooling, distillation, forming, leak test, and others can be used. For example, the machine or the processes used is like this. Okay, medical and pharmaceutical. Here I only list up a product that Alvec offer because I don't have much experience on another type. So in Alvec, we have a micro powder vacuum system. So this micro powder vacuum system can be used for this pharmaceutical, like sterilize the products, drug substance, and intermediate product. Also for the healthcare, food, cosmetic, and some of the electronic material also using of this. Okay, the concept is this one. For example, we want to make some medical pill, so they will do in the solution first. So the solution, they will mix the solution and put inside this machine. Under the vacuum, it will dry out, and lastly, it will become a powder. And the powder size is very fine. So it used for the like drug substance for the medical itself, and then they will do the packaging. And then for production of like vaccine, so now a lot of due to the corona case, a lot of company, they are starting to make racing to make a vaccine. So this one of example the machine can use for the mass production size. This one is a vacuum freeze, and also for the antibiotic and others equipment can be used. And for aviation, okay, aviation industry, like this part and all the engine part inside here, it need to have the surface treatment to make it strengthen by its purpose lah. Okay, here in the aviation industry. Okay, before this, I had explained on the Japan National Space Development Agency in Japan, JAXA. So they have a artificial chamber to create as a space condition. It's a very large chamber, and they use this one is a cryo pump, cryogenic pump. They have a 52-inch, it's very big, and they use 4 cryo pump for this chamber. This chamber they are using to do some product testing inside, especially like satellite. But in Malaysia, I think we don't have a similar industry. But for aviation, maintenance, MRO, major repairing, overhaul, there's using like for this engine part, the propeller, etc., using of vacuum furnaces. That manufacturer, they have a nearby in the Subang area. Okay, then next we go to the semiconductor wafer fab. I think this is more suitable or near to your study currently. I believe you all from microelectronics study. So your study in terms of semiconductor wafer fab processing. So this is a ALVAC line-up equipment. You for your future, if you are working in the wafer fab, there will be under production itself. There will be a lot of a segment or process you will be involved. So you can have a chance to use etcher, ion implanter, evaporator, dry etcher, sputter, annealing, and CVD. So this, I think you all know the detail of its mechanism or its concept. So meaning in one wafer fab company, they will use a lot of technical personnel, engineer, technician involved for this machine maintenance and also process itself. And in a semiconductor also is LED. Like we have a Osram in Kulim, they produce LED from the wafer, and then we have for the silicon carbide power for like we have a Fuji Electric in Kulim, and then for MEMS memory packaging for the back end processors, we do have a lot of back end packaging and offset player in Penang, Ipoh, and I think Johor also. And then bipolar gate IGBT, and then we have a lithium battery, and also PCB maker. They will use a vacuum machine. So what process are involved in this product? So we will go to the next slide. Okay. Okay. Before that, you have any question? Does anybody have any question, or you want to bring it to the end?
So maybe they will ask after your presentation.
Okay, understood. Yeah, let me drink water first.
Okay.
Okay, I have a total 70 slide. Now slide number 55. Okay, I think maybe I can finish it a bit earlier lah. Like I try to, if you guys have any more questions, it's better lah. We can have a longer Q&A. Okay, next we go for the LED device solution. Okay, this is the process to make a LED. You will have a sapphire substrate, and then do the texturing. On the texturing, you will use a etching or etching processes. This is the etching system we have. This is an Alvec lineup lah. So in the market, we have a lot of others maker competitor as well lah. And then we have a multi-layer processes. It will use MOCVD. So CVD basically is a chemical vapor deposition. And then we'll go for the patterning process. So patterning, once you coat on your wafer, then you will start to make the circuit lah, the layer. So the layer, you have to remove unwanted area or etching process. You can use etching or you can use etcher. And then for the electrode process, that means to make the contact, the terminal. We can use PVD, evaporation, or annealing. Annealing is more for the higher temperature processes lah. PVD, physical vapor deposition, use the physical metal, or use the evaporator method. And then after that, we'll involve the patterning again, to make its circuit. Then it have to be scratched again and etching again. And then we have a passivation, PCVD, and go to the patterning again. This is the cycle of LED device solution. But please bear in mind, different manufacturer may be different type of process lah. This just the example from my experience lah. And this involve, you can use like this equipment. So this technology actually is not cheap, because the one equipment will be $millions lah. So that is why the wafer few years ago, the wafer production cost for the 1 square feet cost is really high, and that is why the engineer in this industry also last time they're having a very good payment, because it's a high tech and not much player can offer on this product.
Shah, for the process LED fabrication process, the flow chain that you showed just now, is all available in Malaysia under the Osram, or there will be some process is in Malaysia, some process in Netherlands, for example, in the case of Osram.
Okay, in case of Osram, they are previously not all in Malaysia. Some part they have in China, but now when few years back, when they made the new plant in Kulim, all the process should be here. They bring all the machine here, but what I heard is due to the not 100% utilized. This moment, I'm not sure whether all are created here or some still part are outsourced to the overseas, especially China or the German factory.
Okay, so Alvec is a supplier for Osram or some other company.
We are not a full line. We are not full supplier lah. There's some equipment you are supply, and we are supply more on the components for the pump system lah. And other LED player in Malaysia like Lumilet, they don't have the front end process here. They purchase the wafer from US. they just bring here and they will do the back end process lah.
They do the cutting and the bonding lah.
Yes, they do the
And
cutting,
packaging.
packaging. Yes.
Okay.
Mhm.
Alright.
Okay, then next we go to the power device solution. Okay, power device, it can be used for if latest technology more smart, more what we call smart car lah. So smart car use not use the conventional fuel anymore. It will use lot of power, lot of battery. So this battery must come out from the sort high power lah. It's come from the power device solution. So power device solution instead of car is also in Japan they are used for the train, the high speed train, Shinkansen, and others like general industry also, but majorly in automotive industry like train and car lah. So this power device solution, when they make the wafer, the processors, it will have a front size. The wafer, I think you know the wafer will be round. You will have top and back, front and back. So this front side, back side also they will involve with the process. So this is the process lah. There we have the epitaxial growth, ion implanter, and then oxidation solution, make the contact, the throat and grinding, and then they will flip, do the backside and ion implant again, back metal deposition, and they will do the dicing. So this is the equipment that can be used. For Alvec, because we are a Japanese company, so we do support our customer, Japanese company, which doing the IGBT power. They are using from front side to back side all of our line up equipment lah. But nowadays technology maybe keep changes because in Malaysia just started to do the 8-inch processes lah for our customer. Previously is still a 6-inch size, so it is quite slow lah in Malaysia. So this also the line up of equipment. Actually, is if you can see the model is about the same, because one model it can be used for different industry lah. And then we have a silicon silicon carbide SiC power device solution. So this the process is the same also. Epitaxial growth, ion implanter, annealing. Sorry, this one already. It's about the same with the power device. And then I go for the another advanced package device solution. So we have a TSV, we have a CSP processes. So actually what make the difference is the process and how is it been designed lah. And the equipment used is majorly is about same application. So this one also is lined up from etching. You will use for the sputtering, etcher, and PCB, SMB. Okay, then we have a memory, MEMS device solution for sensor, application for sensor, RF, optic, and for the chip lah, biochip. The process we have from photomask pattern, we'll go to metallization, patterning, dry etch, bonding. This one back end lah, bonding, wafer, and product testing. So equipment here use sputter and etching. And Next is a thin film battery. So this is a thin film battery. Okay, what is the thin film battery? If you remember last time, the smartphone we use is very big. Why? Because a lot of module card, like for the camera, for the CPU, and then for the screen, and then you need a power also battery. So it's bigger, it's a huge. But nowadays the smartphone technology or this IoT, like everything becomes smaller and smaller. But it comes with more high density of function. So this function will have a lot of its own module. So every module required power. So where this power come out, it come from the supply of battery. But if using a normal battery, our battery will become more thicker. But to prevent of this one, they develop a film, small one, that can charge the power and use for each module. That is why the product become more thinner and thinner. So this thin film battery, inside it have is design like circuit. So this process using before it's encapsulated, the battery, the thin film, the thin film battery finally will be encapsulated. So before encapsulated, this is the process of the use PVD, process involve PVD, annealing, rapid thermal annealing, PVD, evaporator, and encapsulation. So this is the equipment using. So you can imagine from now what I explained, you can imagine a lot of technical personnel will be required. So you have a lot of chances on this industry also. Thin film battery, I think like Samsung, they have a plant making a battery in Malaysia. Okay, LED I already explained, sorry. Okay, so I finished topic number 5. Next, we will go to the number 7. We have 10 topics. So number 7 is job qualification and role. Okay, after I explain all the after I explain about the industry, so what is the product, what is the machine, what is the technology involved, then I believe you also will ask, so to work there, what is the requirement there? What is the requirement required? So what is what we need to be ready? So here I just list out from my experience only, and from my reading. For I believe all you will be involved in semicon related industry lah. So any industry, at least it will require you to have a background in science, engineering, physics, material science, or chemical engineering. We will require from the, if engineer above position, require you at least degree, and then if you have master and PhD also is welcome, because a lot of big industry, they are also hiring a PhD level. Last time we thought like the PhD holder will end up like in education only, but eventually nowadays in industry also they require a PhD holder for their R&D division, and of course their payment also is very good. And then of course you need knowledge in vacuum process. So it's good if you have experience in epitaxy, because in epitaxy in Malaysia, not many university also have this epitaxy equipment machine, and the demand of epitaxy knowledge. And sputtering, you can work in a sputtering or plasma, thin film, coating technology, and etc. And of course, when you are working in industry, no matter how it's R&D or production or quality, you are required to have a strong analytical skill and with excellent problem solving. That's why if you have you can attend any analytical skill by using a software or problem solving like 7QC method or others, it will be add on to your experience. And you are going to working with MNC, so it will involve many people. You have to have a good communication skill, and you can perform the good relationship with your colleague internally and externally. Of course, all of company require you have to have a good interpersonal. You also, when you're working, actually you have to have a negotiation skill also, because every discussion, every meeting, there will involve a lot of negotiation, and also influencing skill is better. And why influencing skill I say is better? Like for when you do the troubleshooting, you do the study, you do the analysis, you have to present it to your superior. When you are presented, you have to influence them. That means make them believe on what you're finding. Because to make people influence, also that's why you have to be a good presenter and then good analytical skill with your data. And strong, okay, you have if you handling with machine, you also have to know how to read on the technical, interpret technical data, manual, everything. And some of the process also will involve with knowledge of forecasting, especially on the production. When you are the production, you will have like a target, what is your throughput, what is output required, and then from that, you have to understand your machine capability, and then you do the forecasting to fulfill the requirement, what type of activity or how many what is the plan have to be conducted. And then of course you are working like all of this. Semiconductor actually is MNC, is a global company. You will involve with a cross-functional or global project. So you are not dealing with a Malaysian only, not only with a foreigner in Malaysia, and it required you to travel a lot. Some you have to travel to the HQ to meet with the team and then to learn something. So and then you have to lead of the team or group also. And here, the ability to lead the group of engineer, and then you drive improvement. That means every process we need to do improvement, because in the industry, I can say they're not, even though they have the stabilized processes, but we require a lot of improvement every time, a rate of improvement. So we need to bear in mind, we have to ready on this. Working in different culture, this one is normal, and then everything you do is result oriented, because when a company hires us, they want to see the result. So how we deliver the result is important. That's why we must to be result oriented and organize all the with abilities to deliver by the deadlines. Okay, deadline. If you're working in any industry, deadline is a headache. Everything got a deadline, and you will involve a lot of tasks and a lot of deadline. So you must able to work under pressure also, I think. And then technical skill. Of course, you need technical skill. When you are dealing lot of data, how you analysis the data, then maybe I think you also start using GMP, Minitab, and others analytical software. This analytical software is a really value added to yourself. Not before you join the company, you start to learn. If you have a chance, maybe you can attend some free class or out class. Also, is very recommended. Like it's a good value added to your CV also. And analytical skill, you able to use the SEM microscope, scanning electron microscope, and then others microscope also. And problem solving skill must be familiar with FMEA. FMEA is a failure method. Failure method. Oh, sorry, I forgot. You are forecasting what is the failure you will expected, and then what is the countermeasure on it, and then control plan, SPC, your data, and then works instruction and etc. Okay, good presentation, communication, team working is a standard one. Everywhere you go, you need this skill. Negotiation skill, as I mentioned earlier, you will liaise with a lot of parties. Material, okay. Since this semicon, we will deal with a lot of material characterization. So this equipment, will be helpful to you. And forecasting. Okay, sorry, this one is a repeated one. Okay, this is a skill and useful tool that you can be used for your future career. Okay, now we go to number 8. Okay, number 8, vacuum technology players in Malaysia. There are many, but I just listed whatever come out in my mind. In semiconductor wafer fab. In Malaysia, wafer fab, purely wafer fab industry is not many. I think it's 5 only. We have an Infineon Technology in Kulim, Fuji Electric in Kulim, Silterra in Kulim, Osram Optotronic in Kulim, and then X-Fab in Sarawak. So 4 or 5, all is in Kulim, because Kulim is a high-tech park, so a lot of high technology player are here. And the others related to wafer, we have like Onsemi, Hamada Tech, they are do the wafer reclaiming only. And then Hoya also on the hard, on the mask blank lah. Okay, and then semiconductor back end. Back end meaning after the wafer have been completed, back end they will dicing, slicing, cut, do the wire bonding, and do the encapsulated packaging. This one we have many. I think saturated in Penang, also in KL and Johor. So like here, we have a Renaissance Semiconductor, Japanese company. AIC is a local in Kulim. ADI is an American company. They are doing on the high quality chip lah. Lot of application. And then we have a local Kasem in Unisem. This one both in Ipoh. They are offset, outsource testing company. Inari Semiconductor in Penang, and AIC in Kulim, and Ventures, and so on lah. There are many in Penang lah. And then for hard disk company, hard disk, we have WD in Penang. I think Johor also have WD, and we have a Hoya is more on the mask blank processing only lah. Then they will send to Singapore Hoya for the processing. Sorry, I mistake, because I'm not really understand nowadays changes lah. And we have Seagate, and then PV is photovoltaic solar panel. Panasonic Energy in Kulim, sorry, this one they just closed down. They ceased the operation on last month, their final production, because they are doing a high intensity cell, and their price quite high, so difficult to compete. And we have in Kulim very biggest American company, First Solar. This one they using a cadmium telluride PV chemical. And we have a Chinese player, Jinko Solar polycrystalline silicon PV, and we have TS Solar PV, this 116 multi-crystalline PV, and we do have a few more lah in Malaysia. Okay, then coating or thin film lah. This one is more for the ornament, for the product only, like end product, like GF Technology, Titanium, Oryx Advanced Medical, MYM for the automotive one like in KL. And then optical. Okay, optical is for the lens. For in our lens, in our smartphone, we have a camera lens. So camera lens now it's become more high function. So they need to put and have some additional function lah. We have a niche technology, and I know about niche only lah. I'm not sure others. And then LED, we have Osram, Lumilet, and then heat treatment. Heat treatment is a vacuum heat treatment for the hardening, for the surface treatment process. A few players here. We have a local, we have a overseas also. And then machine maker on the leak check, ALT. This one all in Penang. And then we medical pharmaceutical. I just list out a few lah, which I have live before. Actually, we do have more. And then plastic roll coater. Plastic roll coater is for the food packaging. We have a Torre, we have a Samugul. Okay, this from the Maeda process. We have a semiconductor. You can see here the player, solar, and LED. There's a company name here. Okay. Number 9, our last Japanese working environment. The scene from I'm graduated from Japan, and all the while all my experience is working with Japanese. Only 1 year I working with education in Malaysia lah. The rest I work with Japanese. Can say the environment they try to sustain respect, modesty, and harmony. When they have a problem, they not blame one only, but they blame as a group. So they try to fix the problem. They will discuss a lot of discussion to fix it first. The blame come later, and after that they will do the improvement on the Kaizen. And don't rest on your laurel Kaizen. That means even though you have the smooth, even though you have a proven process, they still have a room for Kaizen. Always improvement, always improvement. Sometimes make headache also. And they quantifying everything. You are working hour also, your time also. They are very particular in this one. It's a more micromanagement. And then they know the whole person. Even though you are newcomer like engineer also, when you are meeting with them, you will be introduced to all members until the top management. And if you notice, their office also are very cramped. That even though manager, senior manager, general manager also will be sitting together with one line, one officers. And punctuality lah. Everybody know Japan is punctuality. That's why they involve JIT, just in time term for the manufacturing. Okay. They are when they are working, they are try to be modesty lah. They are not even. That's why when they have a high rank also, we don't feel like it's very high rank when we meet them. They are very low profile, and their policy is work first philosophy. Everything work, everything is work. Sometimes family also to be later. That's why when you're working, maybe you will lose your free time or your private time. And process also important as a result. Not when you do the process also, they want to know lah. like I heard a Western company, if you can deliver the result, it's okay. But for Japanese, process also important. And they are respecting each other, client, senior, and they are very courtesy, their culture, and they considerate toward each other. And everything when you do, that just mentioned here, process is important. So they report, they communicate, they consult every single thing, even though small matter. That's why a lot of meeting have to be here, to be carried out here. But the challenges there, okay, last, our final topic, the challenges of that culture, Japan, because they can do everything, you have to be multitasking. But for me, if multitasking, you can experience several differential posts and also position. It's good for your experience lah. And they face a lot of deadline, a long time working hour. Yes, a lot of paperwork left for reporting, but if you can control your time management by focusing what you want to do, then you can eliminate the time waste activity. And strong hierarchy, as mentioned, everything, they will have a meeting to make a decision also very take long time. So decision, like for us in Malaysia, we not simply can take a decision. Everything have to consult with the HQ. So sometimes we feel like we are less power also. And then lack of privacy, I mentioned, Japan office are very cramped, so they will all sitting together. That's why you know each other, and when this one you have to, they are like competing each other to do the work lah. Different culture, it's normal. You have to maybe sometimes if they don't understand our culture, there will be some misunderstanding. It's normal. Oh, sorry. And then the decision making, because decision making are very cautious. Even small matter thing, they will call for the meeting, lot of documentation, and it's not fast making decision like American or Western company lah, because Japan way is more conservative, try to minimize the error lah. Okay, that's all for my presentation today. So we have another 11 minutes. So I pass back to the Ms. Anish.
Okay, thank you, Mr. General, for the informative and very interesting talks. All right, ladies and gentlemen, now we come to the Q&A session. So any question from the participants? Anyone who want to ask Mr. Shariza directly, you may ask. If no one, I have one question.
Okay.
So for working in Japan, if we don't have any, let's say we don't have any macam belajar dekat Japan lah kan. So do you think we have opportunity to work in Japan because we don't know how to speak in Japan?
Okay.
We don't have any experience lah.
Okay. Basically, Japan nowadays lah. Now youngest, a lot of them started to converse in Japan in English lah. But I think everybody know even though they are very good or strong at the reading, but by using an email, their English are very good. But when it comes to talk, the pronunciation is a bit different from what we converse, because they are starting to study English from Form 1. That means at 13, they will start to study English. So it's quite late to make a familiarization. But nowadays, they know about this globalization, and a lot of youngsters also, their family actually sending out for the tuition. They study English outside. And now when you are working, if you are working at a multinational company, let's say if you are assigned to the overseas division, I think it will be a problem, because most of the people, they can speak English. But in terms of another division, you will involve with another division, and your daily life also, it will be 100% of Japanese. But I found a lot of foreigners also, expat also, they can't speak Japanese, but they're still working in Japan. Like for if you are pursuing master and PhD in Japan, it doesn't require you to do in Japanese. Only what I know only for the degree level, certificate, diploma degree level only required you to be same as what they receive lah in Japanese. But when you further study in master in PhD, you can do in English. I think from that one you will become international. And even though they are working in Japan also, maybe it's because of they will assign to the English speaker related division. Mostly, I think they are dealing with overseas company lah. So not 100% required for you to understand Japanese, but knowing the Japanese in Japan is really helpful, especially on your daily life.
Oh, okay. So we have the question in the chat box here from the Vincentia. Hello, Mr. Shahrizal. Seeing you have many past work experience, which job position you had was most interesting to you and why?
Oh, quite good question. I think I start to jump doing on the sale nearly 10 years lah. And the rest, half of my past working experience is in sale and past is in engineering, purely engineering. When I do sale, the interesting is I meet a lot of people because more leads, more customer meeting, a lot of people. Both technical and sale also, actually I meet a lot of people and traveling around the world also. But in terms of interesting, I think when I do the technical side, technical hands-on job. When I do the hands-on job, dealing with the human and dealing with the machine is different, because human they have a non-constant factor lah. Everybody is a different character. But when we do a machine, when I manage to solve or deliver the project, I feel very satisfied. So and when I do the engineering job, I can go. Last time my job is a technical support, so I go to a lot of customer and I went into their production or to the manufacturing site lah. So I can see a lot of processes, and it's really interesting. Yes.
Okay. So this is another question from Diani. She asked, what about the food for students who live at Japan? Is that very hard to find halal food there? And can we do part-time job while we do our research?
Okay. Last 20 years when I at Japan, that time is difficult to difficult to source for halal food. But now I just came back from Japan this year on July.
Oh, okay.
My company assigned me for 2 years there, and I bring my whole family there also lah. And I noticed nowadays it's really easy to find a halal food. Surrounding my living area also a lot of halal food shop, and then they have what we call a grocery chain, grocery food also selling a lot of Southeast Asia product, of halal product. And you can order from online also, so it's not really difficult. But okay, it's not difficult lah, back to compared to last 20 years. Senang lah. But okay, and then second question on the working there. If you are study in Japan, doing a master or PhD, you can work, you can do the part-time. I think only the regulation require you to have a permit lah. Maybe you can go to the city hall, apply for the permit that you are to do the part-time. You can, it can, if they approve, you can do. And I think a lot of people also they're doing part-time. And you mostly of the student for master PhD, they receive a scholarship, and scholarship in Japan is quite good for master. For master itself, I think maybe you can earn nearly to 10,000 ringgit Malaysia. So if you alone not doing the part-time also is enough. If already can fulfill for your daily use lah. And then actually you don't need to do the part-time lah if got the scholarship. And lot of for the master and PhD, actually a lot of company or Japan government itself, they are offering a scholarship. So they have a lot of channels you can source for it. No need to study by own pocket lah.
Okay. I hope that explained well. So this one is from Reed. Could you please explain further about Horenso?
Okay, Horenso. Horenso in Japanese is a vegetable lah. It's a sawi. Horenso is a Spanish sawi. So you eat Horenso, you become a stronger person. So actually in this Horenso, they have 3 words here. Ho is hokoku, renraku, so is sodang. Hokoku is reporting. Everything when you do work, every single thing you found, you have to report. I think this one is a good thing, because in our culture, when we found a mistake or we make a mistake, we try to hide it. We don't want to inform. If we inform, we will kena one. So who want to inform, isn't it? But in Japan, even though you make a mistake or you found anything, information, you must share with your superior. It's good or it's negative, you just bring to them. So because this information, it might be affected to our processes, our job process. So we have to inform, and if affected, then we will start the call for the meeting how to fix on it lah. And ho is reporting, renraku is inform. So anything also you need to inform to them. Sometimes it's not related also. Maybe you just inform, okay, this A person from this division, let's say, are sick and taking a long holiday. So they will forecast that, we will liaise with this division, with this guy future. So we have to find another guy for the new PIC or everything. And even though like we are working, we are sick, we inform to them, so they know what is going on. That's in the working lah. But in the process, machine, everything, changes of the parameter, product defect, material change, or any difficulty, machine stop, so we have to inform. And lastly, Horenso. So is sodang. Sodang is consult. We have a problem, we don't know how to make a decision. So we also consult to our superior, and superior will guide. If they have experience, they will guide, or no, we call a meeting again, how to improve on that one. That is why in Japan, a lot of meeting, because sometimes the decision, they don't do decision by one person only. We have to call for the meeting. When I start to working last time, sometimes small information I think is not useful, I don't inform. But at the end, sometimes because of I not inform, there's another problem occurred, so they will blame us back. So to prevent on this one, that is why everything we have to inform and to share. Okay.
Okay. So and then he asked how we could implement this culture in local university.
Is it what Horenso culture?
Yeah. That one, Horenso culture.
First, I think need to I think not everybody know what is Horenso. So first you have to do like explanation session lah, what is Horenso, and then after that maybe some to implement immediately change the culture maybe is quite different, maybe with some requirement in the processes, or because we have nowadays we have what we call this chat everything online, so we can share the information inside. So anything we can share and we can discuss on it lah. Or to make it official, maybe introduce of some method that we can log or report or share information officially, and then some parties or responsible person have to reply on that one, what is the action taken. Because if we just inform only and no feedback written, at the end people will fed up. They won't inform anything because they inform for improvement, but we don't take the action. So this one need to make some group lah. They mean who's responsible on this one, and then what is the flow, everything lah.
Okay. So I have one question again.
Okay.
For the sputtering system, if usually if you want to vacuum to let's say -6 or -7, it's only take 1 hour. But after sometimes we want to vacuum for the same pressure, it takes around 2 or more hours. So what would you suggest?
Okay. Actually, if this one is about leak lah, in vacuum equipment vacuum tool, the leak is very crucial, because once you got leak, how many hours, how big the pump also, it won't fulfill enough to achieve the ultimate pressure. So the leak can come from a few factors. First, from the chamber itself. Maybe the chamber have a leak from the door O-ring, or from any leak valve or any valve attached to the system. Secondly, maybe from the outgas of the chamber itself. Because chamber, when we put material like the target material, the target, the target holder, the shield, everything have outgas. For example, when you're handling the thing without your bare hand, our bare hand have oily or some dirt. We attach to the product. When you put inside, this thing actually is making a gas.
Okay.
So this gas, to remove this gas, the pump need to work more harder. So it will take longer time. And third one is maybe from the pumping system itself. Let's say you are using oil rotary pump. So if the oil have a back flash, so the oil coming into the chamber or attached to somewhere, and this oil grease also have outgas. That is why you need. That's why you take second time will took a very long time. So what you have to do every time when you open the chamber, before you close back, you use acetone or acetone to alcohol to clean. You wipe out, handling with hand with a glove. So wipe out, take all the dirt, the oil, the grease, and then every time to do the cleaning and ensure there's no leak on the O-ring, everything. And time by time you have to do, if you still don't know where is the leak come out, you have to carry out the leak testing by using the helium leak tester. So because helium is a small particle, because when you're using a helium, you can check with what is the leak level. So you can know the leak, and helium also have a sniffer. You can push helium inside and you can check from outside where is the leak point. A lot of things can be done.
Yeah. So either the pump is a problem or there is a leak.
The pump have a leak, or the chamber have a leak, or the outgas from the inside.
Oh, okay.
But
Alright.
as ad hoc countermeasure you can do is do the cleaning timely.
Okay. So any more question from the participants? So I think we don't have any more questions. So okay, once again, thank you, Ms. Sharia, for answering all the questions. So ladies and gentlemen, finally we come to the end of our presentation, and we would like to say thanks again to Mr. Shahrizal. I believe this presentation will be beneficial to our participant in the present and future. So before we end, I would like to call every participant to switch on your camera, and we will have the photograph session